Question 6, same thing. We have a graph and there go around theta. There's a ray up to these points. We drop and make a right triangle so we can find the length of the radius. So we're going to find cosine again and then find our angle measures. So let's start with, here's W, and we have the opposite side, an adjacent side, and then hypotenuse is across from the right angle. And we have cosine, so we need adjacent over hypotenuse. Well, the adjacent side is our x value. We're going back 6 and then up 6 square roots of 3. So let's use Pythagorean theorem to solve for the hypotenuse. So C, and then our legs that make up that right angle, we call those the legs. That's A and B. So I have -6 squared plus 6 square roots of 3 squared equals C squared. Let's type that in. So that's 144. And then to get C by itself, we take the square root of both sides, and the square root of 144 is 12. So our hypotenuse is 12. Cosine is adjacent over hypotenuse. So -6 over 12, which reduces to -1/2. Those both divide by 6. To find theta, we have to first find W. So I'm going to use our right triangle with W. So cosine of W is adjacent over hypotenuse, which we just found was -1/2. And now I'm going to take the inverse cosine of both sides. So those cancel out, and we're left with W inverse cosine of -1/2. So I'm over here to functions, inverse -1/2, which is 120. So that's actually theta. And then our cosine value is the 60. So because we're using cosine, we actually do want theta there this time. But with sine, we had to use the triangle first because of the opposite side. So 120 is theta, and then the 60 is W. And those add to 180. That's how I knew one was the other, because when you add those, it's all the way across to 180.